Welcome back, Math 30-1. Today we are going to look at permutations with restrictions and permutations with repetitions. So our first question here is kind of like a question we've seen before. We're going to look at oranges and we're just going to rearrange them so we can make another word. And the first one says there is no restrictions. So we have 1, 2, 3, 4, 5, 6, 7 letters. So that's going to be 7 factorial, which is the same as 5040. Okay? Now the next part here says the letter N must be the first letter. So in that case, we must start off with N, right? It must be N to start off with. So there's only one case for there. Then we have 6, 5, 4, 3, 2, 1, which is 6 factorial, which is the same as 720. Okay? Now we look at C. It says these vowels must be together, but they must be in that order. So if they must be in this order and together, we could say that's one letter. So this is going to count as one letter. So I have O, A, and E as one letter. Then we also have the choice of B, or then we have all my other choices here. So these are one letter, then we have my other choices, so that's 1. And then we have 2, 3, 4, 5, I believe, because 1, 2, 3, 4, 5, 6, 7. Yep. Other choices. So altogether, if this counts as one letter, we have altogether now only 5 letters we can kind of move around, which gives me 5 factorial, which is equal to 120. All right. Now let's take a look at class example number 2. We have the word brains, but it says the vowels must always be together. So we have 2 ways we could do this. A and I must be together, right? So they could count as one word. So we have A and I, or we could have I and A. The order of them together doesn't really matter. So it's AI or IA. So for these ones, it's 2 factorial for the order of my vowels. Now, they kind of count, however they are, as one letter. Okay? So then, with this, we have the vowels, and then we have the B, R, and S, with my vowels A and I. So now we have 1, 2, 3, 4, 5 kind of orders, or 5 letters now. Since the AI are together, they kind of count as one, or it could be IA. We have 5, so that's going to be multiplied by 5 factorial. Okay? Now when we do this together, when we multiply this, put it in our calculator, we're going to end up getting 240, because 5 factorial is 120, 2 factorial is 2. Now another way of thinking about it is the way we did this before. We said we could go AI as 1, so we could do it with the AI, and that would be 5 factorial. Or we could do IA, which is 5 factorial, which is 120 plus 120, which gives me 240 as well. So that's the other way. This is the way we did it before, but now we're going to use more permutations and combinations and the factorial for that. Okay? All right. So let's take a look at class example number 3. It says, find the number of permutations of the letters for the words kitchen if part 1 is K, C, and N must be together but not necessarily in that order. Okay? This is where it gets very complicated to use this method because I have 3 different ones, so I'd be adding a whole bunch of them together. So first of all, I'm going to say K, C, and N is one letter. So K, C, and N is one letter, but they don't have to be in that order. So I have 1, 2, 3, 4, 5, 6, 7 altogether. So this counts as 1. And then I'm going to have 3, 4, 5, 6, 7. So altogether that is 1, 2, 3, 4, 5. That's 5 factorial multiplied by. Now we have these could be rearranged in many different ways, in 3 factorial different ways. We have 3 terms, which could rearrange those, so that's going to be times 3 factorial, which gives me a total of 720. Okay? Now if we look at B, it wants all the vowels must not be together. So that seems very complicated first. All the vowels not together. Well, we know how to do it if the vowels are together, and we know how to find all the permutations. So what we're going to do is we're going to go total permutations minus vowels together. Okay? Okay, with the permutations vowels together. Now, what this will do is this will give us, we're going to go the total minus the restrictions that we do not want, and that will help us get us everything else, which is what we want. Okay, so what is my total permutations? Well, there's 7 of them, so that's going to be 7 factorial. Now we want to subtract all the ones where the vowels are together. So there's 2 vowels, so that's going to be 2 factorial multiplied by 6 factorial. Because now if they count, these would count as 1 letter, so that would give me 6 factorial. Okay? What does this end up giving me? This ends up giving me a total of, plug it into my calculator, 5040 minus 1440, which is equal to 3600 different solutions. Okay? All right. Class example number 4 says, in how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender could sit together? So we look at this here. We have 3 girls and 4 boys, so that's a total of 7. So 1, 2, 3, 4, 5, 6, 7. So we could have boy, girl, boy, girl, boy, girl, boy. Okay, that's the only way we could do it. Now, the order of the girls here is, the boys is, we could have boy 1 here, 2 here, 3 here, 4 there. So there's 4 factorial for the boys. So it's going to be 4 factorial. And there is 3 factorial for the girls. Okay? So now all we have to do is we multiply 4 factorial by 3 factorial, because there's 4 boys and 3 girls, so that's going to be multiplied by 3 factorial, which is going to end up giving me, this is 24 times 6, which is 144. Okay? And that there is my answer. Alright, so classroom example number 5. 6 actors and 8 actresses are available for a play, with 4 male roles and 3 female roles. How many different casts are possible? So in this case, we have 6 actors for 4 male roles. So out of 6, we need to pick, or permutation, 4. Okay, and then out of 3 females, so then we have out of 8 actresses, out of 8, we're picking 3. There's 3 different roles. Okay, so we have to multiply these together, and I'm going to end up getting 360 multiplied by 336, which gives me a total of 1,296 different cast lists we could make. Okay? So that is the general idea of using permutations with restrictions. So now we're going on to permutations with repetitions. Now, basically what happened is we have our total number of things, and then we're divided by the factorial of how many repeated. So if I have 15 things and there's 3 of one thing repeated, that'd be 3 factorial, and I have 4 of another thing repeated, that'd be 4 factorial, and I have maybe 2 of another thing repeated, that'd be 2 factorial. Okay? So it's divided by the permutations of repetition. So I'm going to give you an example of how that works. So I take a look at the word Vancouver. Okay? Now in Vancouver, we have the V that is repeated twice. So there is a repetition. So I want to know how many permutations are there of Vancouver. Well, that is going to be 9 factorial, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. different letters divided by 2 factorial because the v is repeated twice. Okay? That's why we have the 2 for the 2 v's, which is equal to a total of 181,440. Okay? Now it says, what about the word mathematical? So I look at mathematical. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 different letters. Now what's repeated? I have 2 m's. So that's 2 factorial. I have 3 a's. 1, 2, 3. 3 a's. So that's going to give me 3 factorial. Okay? And then I have 2 t's, which is another 2 factorial. Okay? So it's just how many times each of these are repeated. The letters repeated, that's what we put in the bottom that we're going to divide by. Now this gives me a total of 119, 900,058, and 400. Okay? All right. So let's go to class exercise 7. So it says, Brett bought a carton containing 10 mini boxes of cereal. There are 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Puffs, and 1 box of Shreddies, and the remainder are Raisin Bran. Over a 10-day period, Brett plans to eat the contents of 1 box of cereal each morning. How many different orders or possible orders is there for him eating if on the first morning he has Raisin Bran? So the first morning he has Raisin Bran. How many other possibilities are there? Okay, so we look at this. How many Raisin Brans are there? The remainder are Raisin Brans, 10 mini boxes. So we have 3. So we have 3 cornflakes. So I'm going to write that down. 3 CF. We have 2 RK. I have 1 Cocoa Pops, CP, and we have 1 Shreddies, and the remainder are Raisin Bran. So I look at this, we have 1, 2, 3, 4, so that's 3, 5, 7. So that means we also have 3 Raisin Bran, but he eats 1 of them the first day, we already know, so that's going to leave us with just 2, because the first day is automatically a Raisin Bran day, so that's really only 9 choices now. So it's 9 factorial, all out of, now what's repeated, we have 3 of those, we have 2 of Rice Krispies, and we have 2 Raisin Bran. Okay? So now we put this in our calculator, and we're going to end up getting 15,120 different possible ways he could have his breakfast, starting with Raisin Bran on the first day. All right, so now question number 8. Paul and Catherine are considering the following problem. They want to find the number of routes from A to B if you always must move closer to B. Okay, so Paul arrived at the correct answer by tracing 10 different routes on the grid. Catherine developed a quicker method. She realized that travel from A to B involves moving 3 units east and 2 units south. Okay? And that the answer to the problem is the number of ways in which she can be moving these 5 units altogether. So basically, if we look at this, there are 5 units. We have 3 east and 2 south, so that's a total of 5 factorial. All over, well, we have the 2 south that are repeated, and we have the 3 east that are repeated. So that gives me a total of 10 routes, which is the same thing as what Paul did, except she just used a quicker method. So that is how we do repetitions and how it can help us solve some problems.